Problem 1. In a 5th grade class, there are 35 students. There are 5 rows of desks with 7 students in each row. So that makes sense. We know that if this is the entire classroom, there are 35 students here, and there's 7 students in each row. There's 5 here and 7 here. Every student has adjacent desks that are either in front of, behind, left, or right of the student's desk. If you ask all the students to get up and to sit in another desk that was adjacent to their original one, is it possible for every single student to have a seat? Let's first visualize this. And I'm first going to draw a rectangle and make the line. So 1, 2, and this is not perfect, but it's going to work. Just this sketch is fine. 3 and 5 rows. Okay. Now we're going to have 7 students in each row. So 1, 2, 3, 4, 5, 6. All right, so now we have a 5 by 7, 35 desks classroom. And it's saying that a adjacent desks. What is the definition of adjacent desks? So say this is our original desk. The adjacent desks of this desk would be the one behind it, the one in front of it, the one to its right, the one to its left. And this is going to be the front of the classroom. If it was somebody that was sitting, say, on this side right here, it would be this desk, this desk, and this desk. If it was somebody here, it would be this desk, and this desk. If your desk is connected to the person by a point, that would not count. You have to share a side. So that is our definition of adjacent desks. And the question is it possible for all of these 35 students to get up and to move to a adjacent desk? Now, I'm first going to go over 3 inequalities that we need to know for this series. So the first is black. So the color black does not equal white. We need to know that odd does not equal even. And we need to know that n does not equal n plus 1. Now you might be thinking, well, isn't that just obvious? Black isn't white, odd isn't even, n is not itself plus 1. Well, you'll see why this is so important later on as we start looking at the problems. So first, I am going to take, well, since this is already black, I can't really, alright, I'll take white. And then we're going to turn this kind of into a checkerboard surface. So this is all white, and I'm not fully coloring it in just because we can save time this way. So this is white, and see how I'm starting to make a checkerboard pattern. And this is going to use our first concept that black does not equal white. So there we have it. And we have white spots and we have black spots. Now, how many white spots are there? There are 1, 2, 3, 4, 5. Now, so 5, 10, 15, and okay, so 18. And since in all there is 35 students, then that means that there would be 17 spots that are colored black. 18 and 17. And as you can see, if we look back at the definitions of adjacent desks, we see that if your original desk is black, then you have to move to a white desk. If your original desk is white, you have to move to a black desk. And every single one of these desks fit that situation, fit those rules. Now we can turn this question into something more simpler for more easier for us to visualize. We're asking if we can switch all of the students who are currently sitting in a white desk into with the students who are all currently sitting in a black desk. Well, how many students uh, are sitting in a white desk? 18. And there is not enough black desks for them to switch into because there's only 17. So the answer is it possible for every single student to have a seat? The answer is no, because there is not enough white desks and black desks. So black desks are only 17 and white desks are only 18.